Hello and welcome to the Jaxon Deminar. I'm going to be running through a quick deck here and then I'll get to a demo. I'm going to show a compliance agent in action. But before we get there, I want to tee up exactly what we're doing here at Jaxon and how we are addressing the so-called hallucination problem. So large language models, the ChatGPTs of the world, the Anthropics, the open source varieties, what have you, all LLMs have been architected to look at historical data, predominantly a download of the web called Common Crawl, all of Wikipedia, places like that have trained these models, pre-trained them. And they look at patterns within that data to figure out sequences that makes sense as far as knowledge is concerned, and that knowledge is a representation of the patterns of the data that they have been given. It is not actually doing logical reasoning. They are emulating reasoning, and they've been designed to spit out an answer to a question that you give it or the prompt that you provide, and it's going to placate you and give you an answer no matter what, even if it has to fabricate those responses. And that's what's happening here on this slide is a number of examples where LLMs have hallucinated and costed the companies that were employing them a lot of money. So for high risk, high reward, but high risk applications where you're in a regulated industry and you just have to get the answer right because there's a big downside to getting it wrong, that's where Jaxon comes in. Jaxon is a layer on top of the LLMs. We are creating a workflow that sets up a bunch of rules, which I'll get into in the demo, a bunch of rules that the outputs of the LLMs or any data that's being analyzed, be it an email that someone's written, a report, a chat log, that's being analyzed for compliance against the set of rules that we're imposing. Those rules are taken from existing policy documents within your organizations or from federal regulations. All right, so at a high level, what we're doing is we're taking natural language, free-form text, and we're turning it into a structured language, what we call our domain-specific AI language, which you can think of as code that is ultimately going to be solved. The code is predominantly made up of Boolean operators and assertions that must be met. And if they're not met, then you get that big red X on the other side. In order to solve something, you need to have something like an equation to be solved. Bunch of variables that have new values coming in that are being compared against those rules is effectively what this secret sauce that we are bringing to market has to bear. I like to say, think back to geometry where you were given a problem and you had to show a formal proof to your answer, and every step of the process or every claim that went into your answer had to be right, or the final answer was going to be wrong, and there was only one right answer at the end. Where LLMs not only have this hallucination problem, they're basing their responses based off of probabilities, and they're typically, from what I'm finding, what we're finding at Jaxon here, spitting out different answers to the same questions. So how do you make sure that they are staying in line with not only your domain, but your organization-specific set of rules, vernacular, existing workflows, and institutional knowledge, all imparted into this process so you can trust the outputs. Really unlocking the ability to use LLMs in production is the main theme of Jaxon. All right, I'm gonna skip through a couple of these slides here. I just want to address that the industry right now is leaning on the RAG technique, the retrieval augmented generation technique, which basically means you're giving it representative data, giving the LLM more of a clue as to what the right answers would be, what data aligns to the domain, and how to align to that domain, its vernacular and whatnot. And we recommend it. It makes a lot of sense, but it's still probabilistic. It's probabilities on top of probabilities. And when you have use cases that require a high degree of trust, the far right side is where you are better off. It's tried and true rules that it either is or it isn't. And that's what we're doing with Jaxon, is we're embracing symbolic reasoning, but we're bridging the LLMs, which are very current and new and very powerful and useful, in with the old tried and true capabilities around formally verifying outputs. It's that formal verification process that is really where Jaxon shines. We have a number of agentic guardrails, which, similar to the RAG-based approaches, are probabilistic. We're seeing a lot of lift with these. We're hitting benchmarks that are better than the current state of the art insofar as making sure that the questions are right. But it is not black and white here. It's still a fraction of a percent even of it potentially getting it wrong, which again, for highly regulated or high risk applications, you really want to get to that far right side of rigor, the symbolic reasoning piece, which is what I'm going to show you in the demo. Our policy-based verification process, or what we call our policy rules guardrails. What they're doing is taking in, actually I'm going to go up a slide here, taking in a bunch of guidelines from existing policy documents. Again, this could be internal documents, documents that you're ingesting from federal regulations, what have you. That sets up the rules. That's what we're going to base everything off of, are these policies. You can also freeform text right in a rule. As a subject matter expert, you know something that goes in and above these policies, by all means, you can impart that wisdom as well. And then we're applying those rules that have been extracted in a runtime setting. This workflow is what you'd see in a production or runtime setting, where you have data to be reviewed, whether that's coming from an LLM or any type of document or email, again, chat log, what have you. And we're applying all those rules to it in a programmatic way. So this all happens automatically in less than a second, where every chunk of a document, and a chunk is defined as to up to 1,000 characters, is evaluated against every rule. And you get a spit out on the other side, or a report of what did and didn't pass. It either verified that it was in compliance or it wasn't, or in technical terms, it satisfied the rule or it didn't. All right, I'm going to skip over to the demo now without further ado. So this is the Jaxon platform. We create an application, and then you can have multiple guardrails per application. Many applications you can mix and match, and it requires or warrants you to mix and match agentic guardrails with these policy rules guardrails. Today, I'm just going to show you the policy rules guardrail for FINRA 2210 compliance. So I'll quickly, hopefully, find the actual rule or the regulation here coming out from FINRA. And you'll see it's a quite long document with a bunch of written text that was written by a human for human interpretation. And that's a common theme we're seeing across a lot of use cases, that these policies were written for human interpretation, not machine executed automation. So you'll see that our workflow is to get it to that point. So we'll start with that policy. We do have prompts baked in automatically. The users have the ability to add additional prompts in here. So this one's specifically guiding it toward how to treat this specific regulation. We turn the policy, and this is with a click of a button, and we're using LLMs to do this process. So we click the button, it turns the policy into a bulleted set of rules. The rules are editable, so the operator can come in here and make edits if it didn't reflect the policy properly. We're finding, though, that this step works pretty well. All right, we click another button and it turns the bulleted set of rules into our domain-specific AI language. So this is code you see it's a bunch of Boolean operators and assertions, and this is what's going to be enforced. This is the set of rules. But before we can solve anything, we need to go out and find values to match with those questions or those rules. So we hit another button and we generate questions. Think of this as what you as a human would ask in your head about a piece of information to determine whether or not it's following that policy. We're translating it here back into questions so that these can go out and find representative answers. All these questions are editable. So if it didn't reflect the policy well, the subject matter expert can come in here and edit it. They also can add additional context, which oftentimes is important. But once these questions are set, they get wrapped up into one master prompt. That master prompt goes out alongside whatever data it is that you're trying to analyze. And in our case, let me flip over to it now, we're analyzing emails. So this is a fabricated email. This is for FINRA compliance. Pretend this is a financial services company that wrote this email to someone in the public. And that's what 2210, the FINRA regulation that we're following, is all about, is communications with the public. All right, so it goes out and it hits every one of those rules, and it flags any rule that has been tripped. So in this case, the member name prominently displayed is what's tripped. You can dig back into the section of the email that was tripped, as well as get to the actual FINRA regulation that was tripped, and then take action on it. So these agents, like this compliance agent, are sitting on top of the Jaxon platform, or calling on the Jaxon platform, actually more accurately. It's not sitting on top of it, it's calling on the platform through an API. So this agent that we've created for this particular use case is calling on the API, but any existing LLM agent can call on Jaxon's guardrails to get that extra lift, to get that extra layer of verification. We've designed it in such a way to be those guardrails, not to be the agent. Each one of these agents are use case specific that we're creating. We're creating them on behalf of our customers, but the core platform, the guardrails creation, is what we've designed to be able to be agnostic to industry, agnostic to application. Call on the guardrail, you get the response, and you can display it however you'd like. So happy to talk with anyone about your specific use cases. Please reach out to info@jaxon.ai, and I will pause for any questions. I see someone's asking about deployment model. So for us, we do a lot of work with DoD, where everything has to be in air-gapped environments on their infrastructure. So we've designed our commercial product, which is what I'm showing off here, for containers where you can host it inside of your environments, on your private clouds if you want, on-prem, what have you. But it comes as a container that does not have to touch the internet. Of course, you can add in your API keys for OpenAI and use OpenAI, but we also work very well with all the open source LLMs as well. And that's how we deal with security as well. We wrap within your existing security infrastructure to take care of privacy concerns as well. Okay, any other questions? Overhead. Okay, last question. I'm going to break. I got to go grab lunch. This has been fun. I hope people are still watching. It takes a couple seconds. It adds a little bit of time into the processing. Of course, an engineer would say it depends. It depends on the complexity of the data being analyzed, the LLM being used, whether it's quantized or not, and so forth. But in general, I like to say it adds a couple seconds in. We can probably get that down. And if it's a really complex case, it might take a little bit longer. But in general, it's just a little bit of overhead to get that extra virility into your process. Okay. Any other questions? No other questions? We're good. Let's call this a wrap. Thank you all. Hope you enjoyed it. Talk to you soon.